Okay, we have made it to the end of chapter 5. This is our last lesson, lesson 8, and this lesson is all about factoring. So this is called factor linear expressions. Let's get started. We're going to start with a little bit of vocab. Our first vocab word is the word monomial. And a monomial is an algebraic expression consisting of one term. So a monomial would be 5x or 15x squared y, right? So we're not dealing with any plus or minus. It's just a term consisting of numbers and variables, okay? So one term in an expression. Factor. You've heard the word factor before in 5th grade and 6th grade. This factor is a little bit different. This is the process of factoring. So this is actually a verb. And if I ask you to factor an algebraic expression, that means I want you to express that expression as a product of two or more quantities. So we're going to take it and we're going to write that expression as a multiplication problem. Okay? So let's get started on a couple more notes here. When factoring a linear expression, we are going to do a little bit of dividing. Okay, so we're going to divide, and we are going to divide by the GCF, the greatest common factor of all the terms. And that means that we've got to do a little bit of review on how to find the GCF. So we are going to do a throwback question here. And the question says to find the GCF of 48 and 60. And I've got two methods for that, and we'll go through both methods really quickly. So the listing method just takes our numbers and lists all the factors. And what I encourage you to do when you do the listing method is to start with 1 and start at the other end with 48, because 1 times 48 is 48, and then just kind of keep moving in and doing the next lowest factor and the next highest factor. So the next factor would be 2 and 24, because 2 times 24 is 48, and then 3 times 16. 3 times 16 is 48. 4 times 12 is 48. 5 is not a factor, but we do have 6 and 8. And once we get to the middle here, 6 and 8, the only number between them is 7, and 7 is not a factor, so we know we are finished. So I kind of like this method where we take lowest and highest and list them all. If you don't want to do it like that, that's fine, but make sure that you can list all of the factors of the number 48. We also have to list all the factors of the number 60. And 60 is a bigger number, but it does have fewer factors. So again, I'm going to do my low-high method. 1 and 60, because 1 times 60 is 60. Then we've got 2 times 30, and 3 times 20, and 4 times 15, and 5 times 12, and 6 times 10. And the numbers between 6 and 10 are 7, 8, and 9, and they are not factors of 60, so I know that I got all of them. Okay, so to find the GCF by listing, now all I do is I find the biggest number that's in both lists. Greatest common factor means the greatest factor that's in both of those numbers, and I believe that greatest factor is 12. So, listing method, the GCF is 12. There's another method called the Venn diagram method. This method is pretty great as well. In fact, I prefer this method for larger numbers, like maybe 480 and 600. And what we do is we start off with some factor trees. So I like to start off with something like 6 and 8, where they're kind of both close to the middle. Then 6 can be written as 2 times 3. Both of those numbers are prime, so I like to circle them. 8 can be written as 2 times 4. 2 is prime, so I'm going to circle it, but 4 is composite, so I can split it again and write it as 2 times 2. Okay, so I've got that down to all prime factors, so now I'm going to move to 60. 60, I like to start, again, somewhere near the middle, so that's 6 times 10. 6 can be written as 2 times 3. Both of those factors are prime, so I like to circle them. 10 can be written as 2 times 5. Both of those factors are prime, so I'm going to circle them. When I see that all my factors are prime and circled, then I know I'm finished. So to finish my Venn diagram method, I draw a Venn diagram. Two very poorly drawn circles here, right? And what I do is I take numbers that are in both of these and I put them in the center of my Venn diagram. So I've got a 2 here and a 2 here, so I'm going to put a 2 in the middle. And I've got a 3 here and a 3 here, so I'm going to put a 3 in the middle. And another 2 and another 2, so I'm going to put a 2 in the middle. Now I've got a 2 here and a 2 here, and a 5 over here, and they're not the same, so I'm not going to put them in the middle of my Venn diagram. So I'm going to take the numbers in the middle and I'm going to multiply them together. 2 times 2 times 3 is 12. And that's my GCF. You're probably asking, why am I not using these two 2's and this 5? Well, I would use them if I wanted to find the LCM, but that's a different video. So GCF, you can just take your common factors, your common prime factors, and multiply them together. Okay? No matter how you find the GCF, you're in good shape. Even if you do it mentally, that's perfectly fine too. So let's take a look at some of my examples here where I'm finding the GCF of things called monomials. Okay? So GCF of 15xy and 45y. Okay, so now we can find the GCF of these monomials, these single term algebraic expressions. And it doesn't matter how you find the GCF of 15 and 45, you can do the listing method or you can do the Venn diagram method, but you're going to find that the GCF of those two numbers is 15. Okay, trust me on that. Go ahead and test your math. The GCF is 15. But now we have variables to worry about as well. So x times y, or xy literally means x times y. And here we've got a y. Well, what variable is in both of those variable pieces? It's that y that shows up. So the y is part of the GCF. So the GCF of those two terms is 15y. Let's do another one. With a little more complicated one, find the GCF of 80 a cubed b squared. Well, I'm going to take it and I'm going to write this out a little bit. A cubed is a times a times a, and b squared is b times b. And over here I have 20 a squared b. So that's 20 times a, that's what a squared means, times b. So first I do the GCF of my coefficients. You can do that with the listing method or the Venn diagram method. It does not matter. You will find that GCF is 20. 20 is a factor of both 20 and 80. Now we need to find the GCF of the variable parts. So I've got A. So two A's show up in both of my variable parts. So that means I've got to put a squared in my GCF because a times a is a squared. But we only have one b that shows up in both of our variable parts. So I'm only going to put one b in my GCF. Remember, greatest common factor is what shows up in both of those terms or monomials. Okay? Now let's talk about factoring. So factoring, if you remember the note that we took back here, to express a mathematical expression as a product of two or more quantities. And what that means is that we're going to take this algebraic expression, 24m minus 18y, and we are going to write that as a multiplication problem. So the first thing we do is we set up a set of parentheses, and one of my factors is going to be here, and the other factor is going to be here. And that means that we're multiplying because a number outside of parentheses means multiplication. So what do we factor out of the expression? What do we want to do here. So we want to do basically, we want to find the GCF of both of those terms and put the GCF out here and then divide to see what we get in here. So 24m and 18y, my GCF is not going to have a variable because the m and the y are not the same variable. So we're just going to focus on our coefficients. The GCF of 24 and 18 is 6. And you can do that with the listing method or the Venn diagram method. It does not matter. But what we need to do now is we need to divide both of these terms by 6 to see what we have left inside our parentheses. So 24m divided by 6 is 4m. A negative divided by a positive is a negative. 18y divided by 6 is 3y. And you are going to be tempted to multiply that 6 back into those parentheses, but I need you to stop right there. This is our factored form. Remember, the definition of factoring is to write the expression as a multiplication problem, and that's exactly what we've done. It's kind of like doing the inverse of the distributive property. Okay, I've got 2 more examples. I'm going to make them go really, really fast. Factor the expression negative 10x squared plus 5xy. So set up your parentheses, and we need to find the GCF both of those terms. So the first thing we have to realize is that this negative sign is really important. Since the first term is negative, our GCF is going to be negative. That's weird, I know, but that's just how it's done in math. Okay, so we're putting a negative sign out here. Next, we look at our coefficients. What's the GCF of 10 and 5? It's 5. Next, we look at our variable parts. We've got x squared and we've got xy. Remember, x squared means x times x. xy means x times y. What shows up in both of those? An x. Okay, so what we are going to do is first we're going to kind of do this bit by bit by bit. We're going to divide everything by a negative first. So a negative divided by a negative gets me a positive. Little tiny positive sign there. 10 divided by 5 is 2. X squared divided by x is x. Now we'll do it to the second term. Positive divided by a negative is a negative. 5 divided by 5 is 1. You can put that 1 if you want. xy divided by x is just y. So our final answer here, if we want to make it the most cleaned up, we're going to get rid of that y, or that 1. Our final answer here is negative 5x times the quantity of 2x minus y. That is our factored form. Okay, one more for us here, really, really quick. A rectangular garden has an area of 15m plus 9 square yards. Find a possible set of dimensions of the garden. So what we're looking for is we're taking a rectangle and we know its area, but we want to work backwards to find its length and height. Remember, the formula for area is length times width or base times height. So we're going to take 15m plus 9 and we are going to factor it. So GCF of each of these terms is 3. 15m divided by 3 is 5m. Positive divided by a positive is a positive. 9 divided by 3 is 3. So one possible length is 3 yards. Well, the other possible length is 5m plus 3 yards. And that's how we would answer that question. We would just factor it and then put yards with each term. Okay, lots to think about here. Please work on your practice problems. Please ask questions in class tomorrow because this lesson can be a little bit tricky at first. Okay.